Thanks a lot, Brian. First of all, for inviting me here, and I'm really excited to present this topic. It's something very near and dear to me in general. Just having building software for about 20 years now. So today I'll be talking about how to build a SaaS solution on AWS using serverless. So the idea here is to give you some best practices and how to use various AWS services inside a reference solution. um, so if you are trying to build a SaaS, if you're trying to build a multi-tenant solution using AWS serverless services, this is something you really want to maybe leverage as a starting point. So before I begin, just maybe a quick introduction about myself. I am one of the solution architects here at AWS. I work for a team called a SaaS Factory, and by the name, maybe you can imagine that we help customers who are building SaaS-based solutions on AWS, right? I have been writing code like for about 20 years now. I started my career as a Visual Basic developer back then. And then 3 years ago, I joined AWS, and since then I've been working as part of this team. Outside work, I have a family. I have a wife and two boys, 15 and 10. We live in Massachusetts, and recently we also got a dog, and she keeps me busy sometimes. All right, so let me begin. So I thought maybe it probably makes sense, before I jump into the technical details, to define what software as a service really means. So if you just look at this definition, which we have here, it's more of a business delivery model, right? So SaaS is a way of doing business where you centrally host your application, and your customers come and they subscribe to that application, right? Some examples, if I have to give, think of Dropbox, Slack, Salesforce. These are some of the examples, pretty popular SaaS platforms, which you just go and subscribe. So as an example, for Dropbox, you just buy some sort of storage, and you just pay on monthly basis for the storage. You don't have to like buy a hard disk or install anything on your machine, right? It's just some sort of consumption based model you are following, right? So today's discussion is relevant for both B2C or business to consumer, or B2B or business to business SaaS models. Although I would say that it will be more beneficial. It will be more beneficial if you are working on a B2B kind of SaaS, but you can apply the principles and best practices in both the cases. So I thought it is relevant to show this quote from Jeff Bezos, which he wrote in his 2016 letter to shareholders. And if you just pay attention to this one line, which he says, right, that customers are always beautifully, wonderfully dissatisfied. I thought this was very relevant in this context, because if you're a SaaS provider, you'll have hundreds and maybe millions of customers and tenants in your system, and it becomes really important for you to raise the bar in terms of agility and operational excellence. Just imagine, like, even like a small downtime of 10 to 15 minutes can have a severe impact on your business, right? So it's very important to work backwards and be customer obsessed, and I thought this quote is very much relevant for today's discussion. All right. So now, what it means to be SaaS, right? So, before I jump into the serverless and how to use serverless services, I'll probably have a couple of slides which talks about the high-level architecture patterns or design principles that I need to understand while building a SaaS application. And the first thing you need to understand is, broadly, you can define your SaaS application or design your SaaS application in two high-level components: an application plane and a control plane. So application plane is basically, it's actually your IP. It's the service that you're providing to your customers. So in this case, in the examples I gave, storage as a service or a CRM platform or a messaging service, it's basically your IP, and that's pretty much you're offering to your customers. And this is a platform that obviously is multi-tenant by default. And what does it mean? What it really means is you'll have multiple businesses, multiple customers, multiple users within those businesses who will be subscribed to your SaaS platform and be leveraging all at same time. On the other hand, what we have is a control plane, and the control plane is pretty much what is managing this entire application plane, right? This is basically your platform or set of microservices which are responsible for onboarding a new tenant, as an example, right? Managing the security aspects of a SaaS solution. You'll have some sort of identity management system. You'll have some sort of microservices which will collect the logs and metrics from a SaaS platform and consolidate them together, and then be able to visualize them, right? And then you'll have some sort of microservices which will allow you to provision a new tenant, or maybe provision the resources of a new tenant inside your SaaS platform. So this control plane are basically a set of services which do not need to be multi-tenant. I mean, they are just to control the application plane or the deployment and operational aspects of a SaaS solution. Now, within the application plane, there are two typical deployment models that we see customers follow when they deploy inside AWS. The first one, which is pretty common, is you have dedicated resources for each tenant. So take an example where you have tenant one who is trying to onboard into your system, and you provision maybe a separate EKS cluster or an RDS database instance for them altogether, right? And this model is what we call it a silo model. Basically, you are just provisioning separate infrastructure resources for all of your tenants. Now, the other model is what we call it as pool model. And in this case, as you can imagine, you have your existing or your services or your resources shared across all these tenants. So imagine an RDS cluster or maybe a EKS cluster, being accessed by and shared by all the tenants. And as you can imagine, right, it's probably pretty evident that each model has their pros and cons, right? So in case of a silo model on the left side, you see you have little bit of better compliance alignment. So if you have customers who are a little bit concerned about the compliance and security aspects, or maybe you have tighter SLAs and you want to tune the resources according to those tenants, the silo model will be more suitable in those cases. Whereas if you are trying to maximize your resource utilization, if you're trying to make sure that you have resources which are shared by multiple users and customers and tenants, which gives you obviously better cost efficiency, you probably go for a pool model. Now, having said that, it is important as a SaaS provider that you make sure that proper tenant isolation and security requirements are followed, regardless of what model you choose. In fact, today, the reference solution that we will talk about, I have a hybrid model in place where we will provision some resources or some tenants in a silo model and some tenants in a pool model. And we will actually see how you can enforce the tenant isolation, authentication, authorization in both ways. So let me just jump onto the reference solution that I was talking about, which we have built, which kind of uses all these design patterns and kind of applies them together to build a working solution. I'm going to first talk about the AWS services and features that we leverage as part of this reference solution. So what we did, we first leveraged what we call it as AWS Serverless Application Model, or SAM, and we deployed our resources using SAM. So SAM is basically an open source framework to deploy your serverless resources on AWS. And then alongside, we also leverage CDK to deploy some more components, mainly for the DevOps footprint of our SaaS application. Now, the difference between SAM and CDK, SAM is more like markup. You probably use YAML or JSON. CDK is more programming language. So basically, you can actually write a TypeScript and deploy your resources. The idea was to show that they both can work in parallel and hand in hand. But in your case, you might just choose CDK to deploy your resources. But we intentionally use both just to show how they kind of work hand in hand. So then our API layer was built using Amazon API Gateway. And we specifically leveraged the REST API capabilities of API Gateway to build our API layer. So all our APIs are RESTful APIs. They follow that get, put, post kind of methods. Then for the authentication and authorization purposes, we leverage a feature we called as Lambda Authorizer within API Gateway. And I'll talk about a little bit more detail on how that works in subsequent slides. Another feature that we used was usage plans and API keys. So typically in a SaaS model, if you have multiple tenants who are trying to access the system, you need to be really careful about enabling some sort of throttling mechanisms in your application, right? So think about it that you're trying to open up your APIs to hundreds of customers. What if one customer just run accidentally, maybe run a script and just trying to bombard your APIs, right? So there are chances that your resources might get exhausted. So in order to enforce some sort of throttling mechanisms, we leverage this feature, and I'll show you how that works exactly as well. Then we leverage Amazon Cognito as our identity management platform. And we specifically leverage what we call it as user pools as a feature within Cognito to store our users. So your users can come and register themselves and then later can authenticate themselves using a username password based workflow. Um, then for the compute layer, we leveraged AWS Lambda. And specifically, I will also talk about how we leverage the fine-grained access control using AWS STS service. This is more relevant when you are working in that pool model where a single Lambda function is shared across multiple tenants and users. Like how does that fine-grained access control work? And then we leverage Lambda layers, which is another functionality, a feature inside Lambda service, which basically let you create reusable libraries and share those reusable libraries across multiple Lambda functions. So in our case, specifically, we leverage metrics and logging and authentication authorization, which was more like a reusable pattern, and build them using Lambda layers. And we then, we basically then leverage those layers across multiple Lambda functions. And then finally, I'm not going to talk about this in more detail today, but obviously at the end of this slide, I'll give you some links of the reference solution in which is inside GitHub, which you can go and refer yourself. But there are more features like code pipeline and canary deployments, like how to do traffic shifting between newer version of Lambda. So let's say you're trying to deploy a new version of Lambda function, you might want to slowly shift traffic towards that new function, just a way to automate the canary deployment. So that's another feature that we implemented within this reference solution. And then finally, we use DynamoDB as our layer of storage. And DynamoDB again is a key value store, provides you a great way to store your data in a serverless fashion. One more thing I wanted to mention at this point is that the application plane, as I mentioned to you, is deployed in a hybrid model. So I'll show you how you actually onboard your tenants into the system, but you will see that once you onboard the tenant into the system, the basic and the standard tier tenants are deployed in a pool model. So basically, these tenants will be sharing the same set of API gateway, Lambda functions, and DynamoDB table. Whereas when we create a new tenant as a platinum tier tenant, we actually deploy separate resources for those tenants. Again, the whole concept of tiering, not sure if you are aware of that or not, but typically when you're building a SaaS model, you try to create different sort of tiers for your tenants, and you kind of maybe sometimes provide more as maybe more functionality to certain tenants, provide better SLAs to certain tenants. So the idea here was to show like how you can leverage those tiering based strategies to even influence your architecture in this case. And then the control plane has been built using 4 different microservices, all using Lambda functions. Registration is for registering a new tenant. Tenant management is for managing the tenants, and user management is basically a facade in front of your Cognito. So if you need to use a different IDP instead of Cognito, you just need to change inside this user management service, and the rest of your application doesn't really get impacted a lot. And then finally, we have a microservice for provisioning resources for these platinum tier tenants, and as you onboard. Okay, so let's now dive a little deep, and see, how what you really get when you deploy this baseline architecture, right? So when you get the code from GitHub, you will see in the instructions that you will be asked to deploy the architecture using some sort of deployment scripts. And when you deploy that, the first thing that you will see, you will probably get three different web applications. So the first web application that you will see here is the landing sign-up application, which we built using Angular 2. And the idea here was to automate that whole onboarding experience so your tenants can come and register themselves into this application. Then at the center right here, you see a sample SaaS application. And this is just a example SaaS application. We just took like a very basic e-commerce use case. Um, Basically, it's very simple use case of an order and a product service. This will change depending upon your needs, right? So you might have a totally different use case, but the sample SaaS application will give you like an idea of how to implement multi-tenancy within your microservices. And then we also built a admin console for SaaS providers, again built using Angular 2. And in this case, we basically allowed SaaS providers to manage tenants or onboard tenants, and just be able to add more users into the system. The authentication, as I mentioned, is being managed through Cognito. Then the next thing that gets deployed inside your AWS account is the API gateway. And as I mentioned, you will get a Lambda authorizer, which will be responsible for the authentication and authorization of your application. You will get API keys and usage plans feature built into this authorizer. Now, one thing you might notice, which is a little different and sometimes can get a little confusing as well, that we are not really passing the API key from the UI, right? Normally, typically, the way developers think that they need to pass an API key to the API from the client, which is obviously one way to do it. But in our case, what we actually did, we were generating the API key and mapping to the tenant as part of the onboarding process. And our Lambda authorizer is basically trying to map the API key depending upon the tenant. So I'll show you how that works in a little bit more detail, but we are not really passing API key from the UI, but rather just mapping the API key inside the Lambda authorizer itself. And what that really allows us to do is it allows us to throttle all these incoming requests. So just keep in mind that this API key is by tenant. And the way a typical SaaS solution works, you'll have like a hierarchy, right? You'll have a tenant, like a business who buy your SaaS solution, and you will have multiple users within those tenants, right? Now, the whole concept of usage plans and API key in our case is at the tenant level. So if you have a user who's trying to abuse the system, what that basically means is that abuse is limited within that tenant, because now what you're saying is that, hey, this tenant can only access the API, let's say 100 times in a day, just an example, or maybe a million times in a day, right? And if it tries to go beyond that, this usage plan will not let you do so. Then the next thing that gets deployed as part of the architecture is those 4 microservices, as I mentioned, for registration, tenant management, provisioning, and user management. And then we are also deploying the pooled services for the application plane. So in this case, as I mentioned, we took a very basic example of an order and a product service. So we are deploying this order and product service, which will be leveraged by all the basic and standard tier tenants. So this is something that's getting deployed upfront. And then we are deploying some Lambda layers for authentication, metrics, logging, etc. So this is the basic architecture that gets deployed initially. Obviously, there are some things that get added or provisioned as you onboard more tenants. So that's something I'm going to talk about next, at how that really works. All right, so let's maybe dive a little deeper now. So so far I've talked about some basic concepts. I've talked about the high-level architecture. Now I'll probably talk about some more deep concepts and also maybe show you some code as we go along and how those things really work. So the first thing I wanted to talk about is registering new tenants or onboarding new tenants, right? So if you remember, we had two different user interfaces that we talked about that could be leveraged to onboard your tenants, right? Now this could be, in your case, you might only have one or both. So what we have seen is that if you're kind of trying to operate a B2B kind of SaaS application, sometimes you don't expose your lending or sign up application publicly. You just have an admin console and you just use that to register your tenants. So what you will do is when you register a tenant, the first thing that happens is you invoke the registration microservice. And in this case, and this is, by the way, an open endpoint, right? Registration microservice, because this is something you're exposing to your public, to your customers. And depending upon the tenant tier, so if it's a basic or a standard tier, then you follow a different workflow. And if you are like a platinum tier, you follow a different workflow, right? And the workflow in this case is, as I showed to you like in a couple of slides back, for platinum tier tenants, we are deploying a whole set of AWS resources separately in a silo model. So this service kind of orchestrates some sort of workflow on how to provision a new tenant. And the first thing that happens in this workflow, it's basically creating a new user, a new tenant admin user. And this new tenant admin user is then responsible for onboarding more tenant users later on. And as I mentioned, depending upon the tier of the tenant, this user management decides if I need to create a whole separate user pool incognito, or should I just kind of group all the users within a single user pool. And for those who don't know how cognito user pools work, they are basically a way to kind of group your users, right? So if you have a tenant who wants some sort of settings like multi-factor authentication, different password policies, it makes sense to have a silo user pool for them, right? But if you have tenants who don't really have any unique requirements, you can just pool them into a single user pool. So again, in our case, based upon the tenant tier, we are making that decision at this point. The second thing that happens is actually the creation of tenant inside a DynamoDB table. And this is where you store tenant configurations like tenant name, address, billing information, etc., etc. And then finally, if it is a silo tenant, if it is a platinum tier tenant that requires separate AWS resources, we conditionally invoke this tenant provisioning service to onboard those tenants in a silo model. And I'll actually talk about a DevOps pipeline as well later. I hope we'll get enough time to talk about that, which will show you how you can automate that whole onboarding process across different tenants as well. So I have some code here in the slides itself. Instead of shifting screens, I thought it would be easier if you just look at some of the code. Obviously, you can go to the GitHub repository and do a deep dive. But so if you look at here, this code snippet is from the user management service. And one thing I wanted to highlight here is that so obviously you're getting in the event body, you're getting the user details. You get the tenant ID as well. And by the way, this tenant ID is being generated by the registration service, which then invokes this service, right? So you get all this information, and then you have this uh, Cognito client, and you basically are creating a user inside Cognito at this point. And this is where we are providing all the user attributes. And these two attributes, if I just may pull your attention here, these are two attributes we call as custom attributes. So for those who understand how OAuth and what custom attributes really means within an IDP, this is a way to add some sort of metadata to this user, right? So in this case, we are saying that, okay, this user has a user role, let's say tenant admin or tenant read-only user, and belongs to this particular tenant which is being registered which was being registered, or what tenant this user really belongs to, right? So this is our way of telling inside the IDP which user this tenant belong to. And the way we are enforcing this is by using custom attributes, right? And on the right side, this small code snippet is from the create tenant from the tenant management service. And this is where you have all those tenant attributes like name, address, email, etc., etc. But I am also saving an attribute called as API key here as well. So what I do is, I'm generating this API key as part of the registration process itself and mapping that API key to the tenant inside this tenant management table. And then, we are also saving what user pool and app client this tenant is supposed to authenticate against. So in this case, if you're generating a new user pool per tenant for the silo tenants, this is where we are kind of saving all the information. So basically all the tenant information is being saved inside this DynamoDB table. So at this point, you have onboarded a tenant into the system, right? Now you have a tenant admin who has access to your sample SaaS application, and the next thing your tenant admin or your tenant user will do, it will try to log in into your application, into your SaaS application. So this is actually your application which they will be using in long term, like it could be like a storage as a service or some sort of e-commerce platform, right? So it's important to understand how the authentication and authorization really works in this whole multi-tenant complex system, right? So let's say a tenant user is trying to access the system. The first thing obviously you will do is you will ask them to provide their username and password credentials, right? And basically in our case, since we are using Cognito, we are just redirecting that tenant to the Cognito hosted UI, which provides this nice username password. It's something which is already built in. You don't have to build this username password UI, right? So they will authenticate. So once the authentication is successful, Cognito will send back a JOT token. And in this JOT token, as I showed to you, you'll have tenant ID and user role as custom attributes, right? So now what you will do is you will try to access the API gateway, or your UI, your sample SaaS application will try to access the API gateway. And the first thing that happens in this whole workflow, you will hit that authorizer, which will first of all make sure that your JOT token is valid. It will go back to the Cognito endpoint and make sure that your JOT token hasn't expired. It's a valid token. And then it will build something called as an authorizer policy. And this authorizer policy will do at least two things for now, right? First of all, based upon this user role, it will say that, okay, you know what? Is this user even authorized to access this endpoint, right? So let's say you have a read-only user. You don't want that read-only user to access your post and put endpoints. Probably you only want them to access get, right? So in that case, um, this authorization policy will prevent you based upon the user role. And then the second thing it will do, it will basically provide that API key which is stored inside the tenant management table and enable the throttling. So, or in other words, it will say that, hey, this user or this tenant is only authorized to access your APIs, let's say 100 times in a minute or 100 times in an hour, and so on and so forth. So, and then, once this whole authorization process completes, once the JOT token is validated, once you make sure that your quotas are well within the limits, once you make sure that the authorization is valid, then you actually go ahead and actually call that relevant Lambda function, which is basically your compute layer, right? So this is like a typical workflow that you follow. And I think the important things to highlight here was the whole concept around multi-tenancy in terms of how you manage API keys and how you validate JOT tokens here. Now, just kind of diving deep into the code again a little, right? So this is again a small code snippet I took from the GitHub repository. And if you see this auth manager is basically a Python module. It's a Lambda layer actually. So what we have is we have some methods inside the Lambda layer which take the user role and tells you whether you should allow method or whether you should deny methods, right? So in this case, I'm denying certain endpoints based upon certain user roles, and I'm allowing certain endpoints based upon certain user roles. And basically, you just build that policy and pass to the authorization policy, as I was mentioning previously. Now, the whole tenant isolation is a separate. So I just talked about the whole authentication authorization, how that works, right? The next thing I wanted to talk about was how do you actually enforce tenant isolation into the system. And what I really mean by that is, like, let's say you have data from multiple tenants, multiple users inside your DynamoDB, or whatever data store of your choice, right? How do you make sure that one tenant is not able to access other tenants' data? Typically, like, going back maybe 15 years back, I would say that I will just write a where clause, right, where customer ID is equal to 1, where tenant ID is equal to ABC, and that's probably sufficient, right? But then we are kind of handing over the whole security aspects of our system in the hands of developers, right? So what we are saying that, hey, it's up to the developers to write a code and make sure you have where clause everywhere, and then you test them, and then you test them against all those security measures. So typically that way of isolating tenants is prone to a lot of errors and a lot of issues in general. So in AWS you have a concept of IAM, and I'll show you how you can apply that typically to enforce tenant isolation. So first of all, in a silo model, assume that there is a tenant now who is trying to access the system. It has gone through all those authentication and authorization checks we just talked about. It's all good, and then now it's trying to access your Lambda function. So now, in case of a silo model, we deployed separate Lambda functions and separate DynamoDB tables per tenant. So our isolation story is very simple in our case, right? So in our case, all we are saying is that we will associate this this Lambda function with an execution role, and this execution role have access to only this DynamoDB table, right? So this makes the whole tenant isolation story much more simpler. But in case of a pool model, you can imagine, you just, when you have like a single Lambda function, when you have a single DynamoDB table shared across all the tenants, this way of isolating may not be sufficient, right? So how do we solve that challenge? So in order to solve that challenge, we introduce a concept of dynamic policies. And the way it works is you are able to, at runtime, can inject a tenant ID into a dynamic policy. So this policy, by the way, is stored in some sort of configuration, right? So what you are doing is you are saying that, hey, this policy allows you to make these 5 actions on a DynamoDB table on this particular table, but only allow an action to those rows which start with the primary key of tenant ID, right? And in this case, this tenant ID is basically a placeholder which gets injected at runtime. So let's look at the code and how that actually works, right? So imagine this is one of my code which I have in my Lambda authorizer, and this method get policy for user basically takes 2 arguments, right? User role and tenant ID. And by the way, these 2 arguments are already available to us as part of the jaw token, right? So what we typically do is we decide that for this user role, what kind of policy I need to implement. Do I need to provide like get, or just, or maybe write as well? And then this tenant ID which I get from the jaw token gets dynamically injected into that policy. And then I'm leveraging this service which we call it as AWS STS, and passing that policy to get back credentials which are now scoped to the tenant. In short, what we are trying to do is we are trying to enforce row level security inside DynamoDB, right? So basically, this is a way of implementing a row level security inside a DynamoDB table by leveraging AWS IAM policies. And these credentials, which are now only scoped to that tenant, are passed onto the Lambda function. And when the Lambda function is now trying to access the DynamoDB table, it will leverage these credentials to access the table, right? So in a typical database, relational database, you can think of it as a database user, right? So database users normally have access to, let's say, only database 1, database 2. So you create separate users to give access to different databases, and you basically make sure that's how you enforce some sort of security. In this case, we are basically leveraging the scoped dynamic policies to implement that kind of isolation in a pool model. So as I mentioned, this context or these credentials are passed as to your Lambda function as part of the context from the Lambda authorizer. So this code I actually took from the Lambda authorizer, and this is basically the entire policy I was talking about, the authorization policy, right? And there are a bunch of things that I'm doing here. So I'm passing those access secret key. I'm also passing the API key, which actually enforces the whole. Actually, this is where you actually enforce that whole usage plan as well, right? So you basically pass all this information to your authorizer output, and now when you are into that whole authentication authorization workflow, right? So again, you're trying to access a system. This is a example where you're trying to access in a pool model. Your authorizer is now able to access that IAM STS service I was talking about to get that runtime acquired tenant scope and pass those credentials to a Lambda function. And when now this Lambda function is trying to access your DynamoDB table, you have to make sure to pass, these. So as long as you have that reusable data access layer, which passes the access secret key, you can be assured that that row level security is implemented because of the IAM dynamic policy that we talked about. Now, one more thing I wanted to highlight at this point is how would you partition your DynamoDB table, right? So if you remember, the condition of the dynamic policy I was referring to had a concept that okay, only allow where your shard ID starts with, or where your primary key starts with a tenant ID, etc. Right? Whatever tenant ID in our case. So now in this case, I have 1, 2, 3, 4 different rows for the tenant and a random suffix, right? So the reason I'm not really just putting tenant ID as the primary key is just to avoid that hotkey issue, right? So I'm kind of distributing the workload or just distributing the data across multiple partitions, but still be able to apply that condition by using a string like kind of fashion. So basically all I'm saying is that, hey, this policy is basically applicable where your primary key starts with tenant ID, right? If you want to think of that way. I mean, I totally understand this is a bit of a complex thing to understand if you're not really used to these kind of terminologies. So I will highly recommend that you go back and look at the GitHub repository, which I'll just show you in a minute. And then just one more thing I wanted to cover, and then we'll see if we have any questions, right? So there's one more thing I wanted to cover around the whole CI/CD aspect of this SaaS solution, right? Now you can imagine that you have all these environments. You have a pool environment, you have environment for tenant specific infrastructure, and in a typical SaaS environment, right, our goal should be to make sure that we deploy in across all these environments in a consistent fashion, right? um, in a SaaS environment, you don't do like one-off deployments. That's an anti-pattern. You just deploy everything to all the tenants normally, and you try to keep your versions as much consistent as possible, right? So the mechanism that we came up to do that was that we had a build pipeline. So which this build pipeline was getting the source from the code commit repository. It was building it into an S3. Any test you want to run, you can run right here. And then we were actually leveraging this table that we created as part of tenant onboarding itself. And if you pay attention, right, basically what this start deployment code block is doing, it's basically looping through this table and updating all the stacks in a consistent fashion. So in other words, you just get your source of truth from the code at one time, you build it one time, and then you just deploy across all these environments. So this is a concept which you can probably apply to any multi-tenant system. I mean, in case of EKS, you have a little bit more sophisticated open source tools to do this. But in case of serverless, we build this build pipeline and deployment pipeline concept, which you can follow. There are more concepts I can go deep into, but I'll probably maybe just stop. But just one maybe couple of minutes on this tenant whole routing mechanism, right? So now you have this whole concept of making sure that you route your tenants to the appropriate API gateway, right? So whatever resources for the tenant, you want to make sure that you route. And the way the routing typically works is you have some sort of way of identifying tenants in the UI, right? What we have seen customers doing is they follow an approach called subdomain. So sometimes tenant1.saasapplication.com, tenant2.saasapplication.com. So they build some sort of subdomains to kind of solve that challenge. In our case, we were just asking the tenant to provide the tenant name. And then we had an API which basically took that tenant name and gave you back, okay, what API gateway URL this tenant should be pointing to, like what user pool this tenant should be really pointing to, right? And then we just leverage those settings to redirect to the relevant cognito user pool, and then to redirect to the relevant API, right? So this whole concept of routing is another kind of complex piece that you need to solve when you're building this whole multi-tenant hybrid kind of SaaS application. So this is how the final architecture look like. Eventually, you have a CI/CD pipeline which takes care of deploying across this whole multi-tenant environment. I talked about all these different components already, right? And then your application services are now deployed in a hybrid model where you have pooled tenants and you have certain silos for certain tenants, right? Okay, so there's a lot to cover here, and there are a lot of concepts which I talked about in last like 40 minutes. Um, I would really encourage and appreciate if you want to follow some of the workshops that we have built around this. So if you are trying to build a SaaS application, a multi-tenant application using serverless, I highly encourage you to dive deep into the solution, into this GitHub repository, and I think you'll probably definitely leverage and benefit a lot by following some of the best practices and the guidance that we have tried to provide here. All right, thank you so much, and that's it from my side, Brian. I hope let's see if there are any questions.
There were definitely some questions, and folks, if you want to add some more questions, we've got time to answer them. But we did have some questions, and I'm grateful too because I followed everything, but this is like a little bit above my pay grade, so I'm glad for the question. I'm like, I knew I've dealt with some of these services and stuff inside AWS, but never had to build a multi-tenant
Yeah.
SaaS application. Even though I've worked for companies that have them, um, but not actually done them myself. Okay, so I'll start getting to these questions. We've got one question here. When using Lambda Authorizer with federated identity provider, what is the best way to cache the auth token for some time instead of authorizing on every request in a serverless way?
Yeah, so Lambda Authorizer actually provides you caching. It's an inbuilt feature which Lambda Authorizer provides. All you have to do is just enable the caching. You can cache. In fact, in our case, we were caching for like 5 minutes. So whenever a new request comes in, based upon the JOT token, it will figure out. You basically provide, okay, what's your caching mechanism, or what's the key you want to use for caching, right? So it's basically cache on the JOT token. So it won't necessarily go and make that call every time. It will just figure out that, hey, it's within that 5-minute range, so I'll just cache it and just authorize this particular JOT token. So it's a feature that's already built in. Yeah.
Okay, so basically they don't need to really do anything; it's built in. Okay,
Yeah.
excellent. That's easy. All right, next question we've got. Um, how much latency will be added for the additional STS assume role logic? Is there a strategy to cache it?
Yeah, that's a great question, and thanks for asking. I mean, I ran some tests. I think it was about like 200 millisecond or something when the last time I ran some tests. And for that reason, we are actually leveraging Lambda Authorizer to generate the STS credential. And as I mentioned, we are caching the Lambda Authorizer as well. Another approach which you can take is you can generate the STS credential inside your microservices, right? So you can just take that whole STS concept and generate them inside the Lambda function itself. Um, that that way you don't have to. But the whole point of doing inside a Lambda authorizer was to just cache it and avoid that latency. But there is definitely a very small latency that gets added. Typically, we have we have seen customers not really bothering about that 200 millisecond or whatever. Actually, it's even less than that. I might have screwed up some numbers here, but it's definitely in milliseconds.
Okay. Okay. So not nothing, but not
Something to
necessarily.
be aware of, honestly. Like
Yeah.
if you have a very low latency application, something you should be really concerned and aware
Mhm.
of, and make sure you test with the STS and without the STS, and what behavior you're seeing in application. It's worth considering as a way,
Okay.
right? Yeah.
Excellent. Okay. So next question is uh, this. He says this is basically what we're doing at my current employer. The one thing that it doesn't allow for us is the use of direct integrations like AppSync or step functions in
Hmm.
things like AppSync or step functions. Is there a way to limit the access of those integrations? And if not, is this something AWS is thinking about adding?
So yes, I mean, you are kind of limited in this model to introduce a lambda function even for a basic CRUD functionality, right? In some way or the other. Um, in case of AppSync, I think from what I can remember, there is a way to do the direct integration as well. I don't remember on top of my head on how to do it. I did at one point, maybe as a follow up, I can try to find what I did a long time back. But eventually, if you enable direct integration, you will have to somehow generate and pass the access and secret key as part of the direct integration as well, right? Which normally, also there's a way to do it. Again, you have to build that inside your cloud formation. So it's a complex solution which which I have worked out in past, but my advice would be to leverage lambda function just to avoid that complexity. So the short answer is, you'll be better off if you have a lambda function in between and provide you much more flexibility.
Okay. Okay. And then Jason commented that 200 milliseconds sounds like you're going from a region that is not US East 1 and going to the default US East 1 for the STS calls.
Yeah, again, I need to go back and check my numbers. I mean, I would maybe I ran the test like a year ago, honestly. And there was definitely there was a lag. And yeah, you're right. I mean, typically between US East 1 and maybe US West, that's pretty much the kind of latency. There's definitely an overhead to add STS token, to generate an STS token. But as I mentioned, if you use a Lambda authorizer and you cache that latency, or that latency becomes manageable, right? So because now you're not doing it on the every call, but rather every 5 to 10 minutes.
Okay. Okay, we got one more question. If anybody wants to throw a last minute question, I think we have a couple more minutes. But if you have an additional question, feel free to throw it in the chat or on the Ask a Question module while we answer this one here. How can we make the dynamic policy to work with Dynamo single table design? What would be the strategy for partition key for multi-tenant with single table design?
Well, I mean, you don't even have to worry about dynamic policy for a single table, right? Because as I mentioned, you can just provide that in your execution role which table you want to access, right? So basically you can just say that, hey, um, so let me, if I just go back, right, maybe I can just show you.
Oh yeah,
uh,
sure. I'll share your screen again.
oh, okay. Yeah, so basically you don't need this whole condition block if it's just a table level isolation, right? You can just
Mhm.
say, okay, tenant one, I think I had a slide on that. This one, right? So basically you just associate the execution role with the lambda function itself, and you just say that, okay, this lambda function is only required or is only allowed to access table one, this tenant one order table or order tenant one table, right? So there's no need for you to fine grain access. It's much simpler. You just say that your lambda execution role has access only this DynamoDB table, and basically you are not even allowed to access any other table. So it's all built as part of the lambda execution role itself. Maybe just to clarify, there are like two different concepts we are talking about here. There is a concept of lambda execution role. So basically when you create a new lambda function, you have to tell, okay, hey, what permission this lambda function has, and that is governed by the lambda execution role. So what I'm trying to say is that when you just provide that as part of the execution role itself, it's a much simpler model versus dynamic policy is inside your Lambda function, right? It's inside when it's basically a runtime construct. You can't apply that as part of the execution role itself. So it gets much simpler just because of the execution role in a silo model, actually.
Okay. All right. So I think that's all the questions we have. I shared the GitHub repo because this is basically they can take this entire application and just modify it and build upon it and deploy their own
Yeah. In
SaaS
fact,
solution. Essentially, is
in
what you built.
exactly. If you share my screen again,
yes,
I'll probably
it's
just
shared.
yeah. So this is a workshop. The link I mentioned. So this workshop actually do a good job in breaking out into steps, right? So this is a complicated thing to understand and to absorb in one go. So this workshop actually takes you through that whole journey. It kind of first talks about it talks about those SaaS shared services. It talks about how to add multi-tenancy. Then it talks about the dynamic policy. Then it applies those tiering based concept and then tenant throttling. And in fact, recently we also added this lab 7 into this workshop, which actually talks about how you can attribute cost in a pool model, right? And all those links I did mention here at the end. A second,
Yeah.
sorry. So this
So
workshop link first
Nancy
share
is
is
Nancy was asking if we can paste those into the chat or something so that they can.
yeah, 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 yeah,
Um,
yeah.
yeah, if
Uh,
you, I don't know how to
Hold on.
get them off. Are you on the Crowdcast chat? If you can paste them in there.
I can go there.
Otherwise,
Yeah.
sure. Okay. So Nancy, we'll get you those links. Otherwise, you can maybe even just screenshot this right now and save and get them off there as well. So in Anubhav, if you send me, I can actually might be worth if you don't mind sharing the slide deck, and
Of course.
I'll post it with the presentation on the site as well. Yeah, I know you can't click them off the screen. She mentioned, but so we will share them as well. Well, I think that's it for our time. This was this was actually fabulous. I know there was a lot. You covered a lot of stuff in a very short time, and I appreciate you kind of working to cram all that in for our.
Yeah. Sorry about that. I know, right? I
Yeah,
mean,
no, that was great.
okay. Yeah. I mean,
Yeah.
yeah. Please follow the links, and you'll be fine if you want to dive deep further.
Okay. Okay. I will. So, folks, I will share those links as soon as I have them, as well, and I will post the once Anubhav sends me. If you go to cfe.dev and you go to this event, I will actually post the link to the PDF as well.